You've never seen a plane this big before. Designed to carry the shuttle between California and Florida, this colossal beast would be the biggest real aircraft ever designed by the United States. And it's built from the remains of two B-52 bombers. That's right, the engineers looked at the longest-serving bomber and thought, instead of dropping bombs, what if it was redesigned to drop space shuttles instead? And I do actually mean that last part, because apart from just carrying the shuttle between launches, it was also designed to be a launch platform itself. Everything from the shuttle to rockets to even submarines. I'm not kidding, literally submarines. And best of all, it would be cheap, efficient to fly, and be ready for action in only 2 years. This is the egomaniacal fever dream of a visionary, the gargantuan Conroy Virtus. The Space Shuttle is possibly one of the finest aircraft ever designed and built. It's literally a plane that could fly into space, hence the name aircraft, although it does have rockets. But it could return and land on a runway of its own power. But did you know that it was also designed to have its own onboard engines for flying around, moving from the landing zone to the launch site, as well as controlling where it came down? Alas, like all good things, the engines were removed from the design due to cost and weight concerns. And a new problem arose. How would they ferry the new upcoming space shuttle around America? Enter John M. Conroy. Famous for building the Pregnant Guppy and the Super Guppy oversized aircraft that made the Saturn V rocket to the moon possible, he jammed at the bit to develop a new oversized transport plane that could carry this new shuttle, and perhaps even launch it from altitude to save on rocket fuel. In 1974, the team at Conroy's company, the Turbo 3 Corporation, sat down with NASA and came up with some primary requirements for this mega craft. The first one was to safely drop the orbiter from an altitude of approximately 35,000 feet. It also needed to be able to transport the orbiter coast to coast non-stop, or from the Hawaiian Islands to the west coast of the United States. It also needed to operate from normal jet runways, which was around 150 feet wide and 6,000 feet long, with no special airfield requirements other than perhaps a widening of some taxiways and a loading pad. That's right, it wasn't just Mr. Guppy, but Lockheed and Boeing were also going for this contract as well. And that's something that you need to keep in mind, because anything you do, it's all about using the best tools to beat the competition. So about the competition for this project, Lockheed would propose a twin fuselage C-5 Galaxy with the shuttle in between, much like the AN-225 shuttle carrier that was under development in Russia, and then Boeing themselves would propose the 747 as a solo aircraft or a dual fuselage plane as well. This made the contest for Conroy even tougher because both Lockheed and Boeing were bringing planes that could already do the job, and they were already building them. This means that they didn't have to design their planes from scratch and figure out how to build them, making their bids significantly cheaper. Conroy would have to follow suit and somehow find a plane that could be used as a shuttle carrier with some modifications, and also be cheaper than a C-5 Galaxy or a 747. And ironically, there actually happened to be an aircraft that fit the bill perfectly: the B-52 bomber. The Conroy Virtus, for the lack of a better word, would be cobbled together with parts from two B-52 bombers. There would be 4 engines with a large high wing with twin-tail booms and large vertical tail surfaces. The total wingspan would be 450 feet or 140 meters wide, so that's pretty damn big. As the most expensive part of building a plane from scratch is the cockpit, landing gears and associated components, using that from the B-52 bomber would save significant time and capital. The pressurized cockpit made for 3 crew members would be perfect for those long flights, with a comfortable rest area and space for additional crew if needed. The left cockpit would be used for flying the plane, while the spare right cockpit would be used for technical personnel and cargo monitoring, such as when there was an air launch. And while the weight of the aircraft would not exceed that used by the B-52 landing gear, a third landing gear would be incorporated when it loaded the space shuttle to help spread the load over the ground and prevent any damage to the runway. Remember that this plane was designed to be used on normal airports. There was also room on the B-52, particularly the bomb bays, that could be re-engineered as a cargo storage for additional equipment. Apparently there would also be a stand-up passageway between the two fuselages through that top high wing, so in flight if personnel needed to walk over they could, although it wouldn't be pressurized. They would need to use bottled oxygen and have a buddy system to not get stranded. There was also a few different cargo configurations that this aircraft could be used for. To carry the shuttle and drop it off in the air, there would be a special scaffolding that would attach to the shuttle with 4 hardpoints that would allow it to detach and fly away. The second configuration was the transport mode, which would have 2 large thick struts that would secure the shuttle and then carry it underneath the aircraft. There was also a guppy style cargo hold that could be attached to carry the large rockets or any other large materials that were required for the program. The whole aircraft would have a range of 3,000 nautical miles, flying at around 275 miles per hour, costing around $1,000 per hour to operate. Well, plus fuel. You gotta love that in the 1970s they didn't really consider the fuel to be much of a budgetary issue, which, would completely change a few years later. And the best part was that they planned to build 2 of them at around $12.5 million each, which is the equivalent of $60 million US today, and operate them for 25 years. What a bargain! And they were that confident in the design that it could be built in the next 2 years as soon as they got the green light. So, I have to ask, why did it never happen? The Virtus design was tested in the NASA Langley Wind Tunnel. While the results of the wind tunnel tests were considered promising, there were some concerns of how exactly to build such a large aircraft. And boy, Conroy's solution was as big as the aircraft and clearly explains why it never actually happened. So prepare yourself. To start, the B-52s would be acquired, air quotes, and then disassembled in Arizona, with the required parts being shipped to Southern California by road, rail, or guppy to near the construction site of the shuttle. And I love this part of the plan because it assumes 2 things. The first is that the guppy would be used again, surprise, to earn even more dollars for Conway, but also that there would be B-52s ready to retire in the early 70s. Not still in service today. Next up, the B-52s would be transported to a vast hangar in Southern California. This hangar would be built at Oxnard Air Force Base or the nearby Point Mughal Naval Air Station. Why a Navy base, you ask? Because, and it says this in the report, they're the next natural customers of the Conroy Virtus program. For submarine rescue craft, parts, disabled vessels, aircraft, and helicopters, this bad boy could transport anything. God, I love this guy and how audacious he is that he considered it to be a submarine transport aircraft. But this hangar would have to be huge. An inside-outside design, it could build the twin fuselages within the hangar, and then once the wing went on, it would be rolled outside for testing. In the left end of the hangar, there would be manufacturing and sub-assembly locations and areas for machine, hydraulics, sheet metal, and electrical shops. There would also be a giant swinging door that could act as a cover for rainy days. And you're probably wondering, why am I going into so much detail about this giant hangar? Because this one hangar would cost 75% of the same as 2 of the aircraft in this program. That's millions of dollars for a hangar to build just 2 aircraft. Naturally, Conroy argued that it was better than other rentable hangars, as the lifespan of the 2 aircraft would accrue over 50 combined years, but it is a still staggering cost. To combat this fear, Conroy suggested subcontractors could build the majority of the wing, with company personnel flying in on a private jet to supervise. Yes, a leased private jet that the government would also have to pay for. Sheesh, man. Come on, he's not even trying at this point. For the government, the cost of developing an entirely new aircraft, flight testing the design, and the sheer size of the aircraft requiring development or expansion of infrastructure to support it, it militated against further development. And that would be the killing blow of this mega aircraft. So NASA would have to turn to the competition. The Lockheed Corporation, which had proposed a twin fuselage version of the C-5 Galaxy airlifter to carry the shuttle, also saw its proposal rejected for similar reasons. A more modest conversion of existing C-5 Galaxies was proposed and nearly taken up by NASA, but it was determined that having an aircraft that was continually available was preferred to being the restricted version used by the United States Air Force, who wanted to keep the C-5 Galaxies to themselves. Thus, that only left the proposal by Boeing for a conversion of the 747 airliner, which we know today would become the shuttle carrier aircraft. Not to be knocked back, Conroy also proposed a commercial version of the Virtus design named the Colossus, but it also failed to gain any further interest, and thus the entire program was abandoned. And unfortunately, we never got our ridiculous carrier. Or did we? Today we do have the Scale Composites Model 351 Strato launch, otherwise known as the Rock, which was built from two 747s to launch rockets. The aircraft features a twin fuselage design and it has the longest wingspan ever flown at 385 feet, which is 117 meters, which is actually smaller than the design proposed by Conway. But despite flying 13 times and being a modern recreation of the Virtus, this program also failed and went bankrupt. On May 31, 2019, the company announced that it would cease operations and the sale of its assets were being explored with an asking price of $400 million. This would include the aircraft, the company facilities, its designs, and any other intellectual property. It just seems like no one could make this type of aircraft work. Another firm actually did end up buying the plane and the company and is now trying to hawk it for high-speed flight test services, but not rocket air launches. Although there was talk of a larger concept vehicle such as the Talon Z and Black Ice that could carry cargo or people to orbit off this aircraft. So you never know, maybe the Conroy Virtus will fly again.